Hello everyone, welcome to the next lecture of finite element analysis. In today's class we are going to start analysis of rectangular or quadrilateral elements. So I am going to start a new lecture today, a new topic which is the analysis of rectangular and quadrilateral elements. So these type of elements are taken into consideration when you are performing analysis of plates or sheets. For instance, let's consider you are performing an analysis of a plate. So you have a plate which is subject to different type of forces, like let's say a pressure force is acting here on all the sides of this plate, P1, P2 and all the sides of this plate. So the basic idea of finite element analysis is to discretize the element. That means we have to divide this element into number of simpler elements. So we have to divide this component into number of simpler elements. So let's say I am dividing this into these type of elements. So these are rectangular elements. Why I am dividing this into rectangular elements? Because the complete model and the element has got the same shape. So you will get the different types, the same type of displacements as we are getting in the model. So we are not going to analyze the complete model. We are going to take only one simpler element or one element of this model, a few elements, let's say, and we are going to apply loads on that element and we are going to perform the analysis. So in this type of analysis where we have got plates and sheets type of things, so we are going to make use of rectangular or quadrilateral elements. And what's the difference between rectangle and quadrilateral? Rectangle has got opposite sides same. So if we have opposite sides same, so that is rectangle, and a quadrilateral also has four sides, but all the sides might be different. Okay, so a quadrilateral has got four sides, so those four sides may be different, it may not be, it may be same, it may not be same. So any shape which has got four sides is quadrilateral. So we are going to study about the four noded, these are called as four noded quadrilateral elements. So one node, second node, third node, fourth node. So 1, 2, 3, 4. So a rectangular or a quadrilateral element has got four nodes, 1, 2, 3, 4. So how can I define a rectangle? So I can draw a rectangle by giving these four vertices or these four nodes of a rectangle. So if we are modeling a rectangle, we need four nodes. So this is my one node, node 2, node 3 and node 4. Let's say one has got x1 and y1. This is x2, y2. This is x3, y3 and this is x4, y4. So if we remember, when we are using a software, we have got many methods of drawing anything. So I can also draw it by drawing one point at the center and I will pull this point. So we can define one point at the center. So this point P can be anywhere and this is called as local point. So this point is called as local because it is within the element, and these are called as global points. So these are global coordinates and this is within the element, this is called as local or natural coordinates. So this coordinate here is denoted by eta or xi. The system takes this coordinate in this form, that is eta and xi. We can use any other notation, but since textbooks are following these notations, so we are going to take this coordinate as eta and this as xi. Okay, so in this case at eta and xi, usually at center it will be 0 and 0. If we have to go to the bottom it will be -1. If we have to go to the top it will be +1. So we can determine a rectangular or a quadrilateral by giving these 4 points or by giving these points eta and xi with these coordinates. Okay, and there is relation between them and we are going to write down all these formulas here. So the first formula is shape functions. So shape functions are n1, n2, n3 n4. So 1 minus xi into 1 minus eta by 4, 1 minus xi into 1 plus eta by 4, 1 plus and minus, plus here and minus here, and this is 1 plus xi into 1 plus eta by 4, and this is 1 minus xi into 1 plus eta by 4. See how to remember these formulas. It's quite simple. First we have minus minus, then plus comes here, then this plus will also travel here, so plus plus, then again minus here. So all four possibilities. So we have got n1, n2, n3, n4. So these n1, n2, n3, n4 are called as shape functions, which will help us in determining the relation between these coordinates and these coordinates. So once we start problems, you will be able to understand how we are going to use these formulas. So this value, after obtaining this value, the sum of these values should be equal to 1. So you can also verify this if you have got the correct answer of n1, n2, n3 and n4. Okay. Yes. So the second formula is to find out that relation. For example, this point is in terms of x comma y. Can we find out this point in terms of x comma y? Yes. So we can find out that x and y, so at point P, so we are going to determine this point P, which is in the form of xi and eta, in terms of x and y. Okay. So xi and eta will be given in the question, and these values will be given in the question. But at this point, what is this xi and eta in terms of x and y? So we can determine that by using this formula, n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. Similarly, we can find out y also, that is n1 y1 plus n2 y2 plus n3 y3 plus n4 y4. So these are the coordinates. And what is the displacement? So displacements will be given at this point, u1, u2, u3, u4, u5, u6, u7, u8. So because of these forces, this point might move. So that is the displacement u1, u2, u3, u4, u5, u6. So we have to determine the displacement at this point. So we can also determine the displacement at that point. So displacement at that point, any point. So displacement formulas are u is equals to n1 plus n2 plus n3 plus n4. So just write down the odd values here, u1, u3, u5, u7, and the formula of v is n1 u2 plus n2 plus n3 plus n5. Just write down even values here, u2, u4, u6 and u8. So as soon as you have problems on this type of elements, first we have to determine the values of n1, n2, n3, n4. This xi and eta will be given in the question. So after getting those values, you can find out the coordinates x and y at any point P. At any point P where xi and eta is given. So xi and eta has been given in the question, and you have to find out what is the value of x and y at this point. So I have to find out by using this formula and this formula. And you can also determine the displacement at this point P by using this u and v. Okay. If it's clear, I will proceed with the next formula. So the next formula is Jacobian matrix. So formula number 3 is Jacobian matrix. So sometimes in the exam the examiner asks us to find out the Jacobian matrix. So this matrix also helps us in determining the relation between x and eta. So the formula is Jacobian matrix is given by dou by dou xi, dou by dou xi, dou by dou xi, dou by dou xi, dou by dou eta, dou by dou eta, dou by dou eta, dou by dou eta. So here we have to write down n1, n2, n3, n4. So these n1, n2, n3, n4 values we already got from this formula. So we can substitute here. Again n1, n2, n3, n4 into multiplied by this matrix x1, y1. These coordinates are also given in the question. So x1, y1 will be given in the question. So x1, y1, x2, y2, x3, y3, x4, y4. So if we multiply these two matrices, we are going to get the Jacobian matrix. So the next formula is strain displacement matrix. So strain displacement matrix, this formula is a bit lengthy. So strain displacement matrix B is given by dou by dou x1 0, dou by dou x1 0, dou by dou x1 0, 1, 2, 3, 4, 5, 6, dou by dou x1 0. So here you have to write down n1, n2, n3, n4. In the second row you have 0, dou by dou y1 0, dou by dou y1 0, dou by dou y1 0, dou by dou y1. Again you have to write down n1, n2, n3, n4. And in the last row, first write down this value here. Next you have to write down this value here. Similarly, this value here and this value here. This value here, dou n3 by dou y1, and this value here. So differentiation we can do, okay, once we get n1, n2, n3, n4 values, we can perform differentiation, and we are going to do it while solving the problems. This value here and this value here. So this is a strain displacement matrix. We have got 3 reference textbooks, so I have used Chandra Putla, which has given us the easiest way to remember this formula. So in Jalaluddin textbook you have a different formula, but the final answer will be same. So this formula is the easiest one to remember. So once we get the strain displacement matrix, the material matrix formula, material matrix D formula is same as triangular elements. Okay, so this D formula, what was the D formula there? E is equals to 1 by 1 minus mu square, 1 mu, mu 1, and this was 1 minus mu by 2, and these were zeros. So this was the formula for plane stress. This formula was same in triangular elements as well. And for plane strain we had D is equals to 1 by 1 plus mu into 1 minus 2 mu. Just refer those formulas. 1 minus mu, 1, this is mu, 1 minus mu, 1 minus mu, 1 minus 2 mu by 2. So I hope you all remember these two formulas. This was the formula for plane stress and this is the formula for plane strain. If nothing has been mentioned in the question, you can use assume plane stress condition and you can make use of this formula D. Okay. So once we get the matrix B and matrix D, we can find out the stresses and strains. What is strain? Formula number 6. Strain formula is B multiplied by U. So once we get this B, if we multiply U, what is U? U1, U2, U3, U4, U5, U6. So if we multiply those two matrices, we are going to get the strain. And the last formula is stress formula, which is given by sigma, which is D into B into U. So if you remember these 7 formulas, you can solve any problem which has been asked in the exam based on rectangular and quadrilateral elements. So I'll just quickly recapitulate what we have studied today. So if rectangular and coordinates are given, so first step is to find out D1, N1, N2, N3, N4. These values will be given. So after we get those values, we can find out the coordinates at point P. So at point P, where xi and eta is given, we have to find out x and y. So we can find out by using this second formula, this formula. So you can find out xy here, and you can find out the displacement also based on the forces u and v at that point P. So the next formula is Jacobian matrix. Sometimes he'll ask us to find out the Jacobian matrix. So Jacobian matrix also gives us the relation between these coordinates and these coordinates. So this is the formula of Jacobian matrix. In Jacobian matrix, first we have to find out n1, n2, n3, n4, and after doing differentiation, we are going to get this matrix. And these x1, y1, x2, y2, x3, y3, and x4, y4 will be given in the question. Next is a strain displacement matrix. We have again n1, n2, n3, n4 values. If we perform differentiation, we are going to get the strain displacement matrix. So next is material matrix D. These formulas are same as that of triangular elements. So for plane stress, we have this formula for D, and for plane strain, we have this formula of D. Okay, and once we get B and D, if you multiply BU, we are going to get strain, and if you multiply DBU matrices, we are going to get stress. So I am going to solve the first problem. I'm going to solve the first problem on rectangular and quadrilateral elements. So you have to remember these 7 formulas in order to solve any problem on rectangular or quadrilateral elements. So I am writing down the first question. For a 4-noded rectangular element shown in the figure, determine the following. Number 1, Jacobian matrix. Number 2, strain displacement matrix. Number 3, element strains and fourth one is element stresses. So this diagram has been given in the question. So this is a rectangular element. So there are 4 coordinates given, 1, 2, 3, 4. So this is given as 0, 0, and this is given as 3, 0, and this 3 is given as 3, 2, and this is 4, 0, 2, and this point is given. All dimensions are in centimeter, not millimeter. So till now we have been solving problems on millimeter, and now we have got centimeter, and I will show you how to convert everything in terms of centimeters. And this is given in the question. Take E is equals to 70 GPa. Mu is given as 0.25, and eta is 0, and xi is given as 0, and this displacement values has been given in the question. So u is given as 0, 0, 0.002, 0.003, 0.005, 0.004, 0, 0 transpose. This means these are the values of u1, u2, u3, u4, u5, u6, u7, u8 values are given in the question. And in the question he has given us to assume plane stress. So first we have to find out the Jacobian matrix. In order to find out the Jacobian matrix, we need shape functions. But before solving this problem, if we notice in this problem, the dimensions are in terms of centimeter. So everything which is given in the question should be in terms of centimeter. So each and everything should be in terms of centimeter. So these dimensions are in terms of centimeter, and this is given as gigapascal. And what do you mean by gigapascal? Giga means 10 power 9, and Pascal means, okay, I am doing this part has not been given, so I am indicating this part with a red sketch. So 70 into giga means 10 power 9, and Pascal means Newton per meter square. I don't want meters because these dimensions are given in terms of centimeters. So I have to convert this meter square in terms of centimeter square. I don't want any dimension in terms of meters now. I want in terms of centimeters. Okay. So here, in order to convert this meter square into centimeter, what do you mean by centimeter first? Centimeter. I already told you that centi means 10 power minus 2 meter. So now what will be meter? So meter is, if we send this 10 power 2 to the other side, it will become 10 power 2 centimeter. So I know that meter is 10 power 2 centimeter. So here in this place, I am going to substitute that. Okay, I'm writing this here because the space is not sufficient there. So 70 into 10 power 9 Newton by, I know that meter is 10 power 2 centimeter. So in place of meter, I am writing 10 power 2 centimeter. So on this meter you have power 2. In place of meters, I have written 10 power 2 centimeter. Meter square. Now this is meter. Meter means 10 power 2 centimeter. On this meter you have power 2. So power 2 as it is. So here 70 into 10 power 9 by Newton, 2 2s are 4. So this is 10 power 4 centimeter power 2. So centimeter square. If we take this 10 power 4 to the numerator, this will become 10 power 9 minus 4. So that is 70 into 10 power 9 minus 4 is 10 power 5 Newton per centimeter square. So this conversion I have done here. So I am going to erase this part. So this conversion in terms of centimeter is 70 into 10 power 5 Newton per centimeter square. So 70 into 10 power 5 Newton per centimeter square. You don't have to erase that in the examination. Since I have very less space on this board, I am erasing that part. Okay, so after converting in terms of centimeters, I got this E value. So everything is in terms of centimeters now. So first thing we are going to do is find out the Jacobian matrix. So before solving the Jacobian matrix, we should know the formula of Jacobian matrix. So Jacobian matrix is my first bit. So Jacobian matrix is given by dou by dou xi, dou by dou xi, dou by dou xi, dou by dou xi, dou by dou eta, dou by dou eta, dou by dou eta, dou by dou eta, multiplied by x1 y1, x2 y2, x3 y3, x4 y4. So this is the formula of Jacobian matrix. Here we have to write down n1, n2, n3, n4. Similarly n1, n2, n3, n4. So in order to find out Jacobian matrix, we need n1, n2, n3, n4. So first we have to find out that n1, n2, n3, n4. So n1 is, what is the formula of n1? 1 minus xi into 1 minus eta by 4. Okay. What is n2? 1 plus xi into 1 minus eta by 4. What is the formula of n3? 1 plus xi into 1 plus eta by 4. And the formula of n4 is 1 minus xi, okay, plus xi and 1 minus xi and 1 plus eta by 4. So this xi and eta is given in the question. So xi is given as 0 and eta is given as 0. So 1 minus 0, 1 minus 0 by 4. So this is 1 minus 0 is 1, 1 into 1, 1 by 4. So all these are 1 by 4s. So this is also 1 plus 0, 1 minus 0. Just substitute this, you are going to get 1 by 4 here, 1 by 4 here and 1 by 4 here. It depends on these values of xi and eta. Since xi and etas are 0, so 1 plus 0 is 1, 1 minus 0 is 1. So 1 into 1, 1 by 4. We are going to get these values here after substituting xi and eta. So this is called as xi and this is eta. Okay. So we got the values of n1, n2, n3 and n4. So now what is Jacobian matrix here? Yeah, so first dou n1 by dou xi. Okay, so what is n1? N1 before substituting. Let's not consider this part because we have to perform differentiation here. If you perform differentiation, everything will become 0 because differentiation of constant is 0. So first we have to find out the differentiation of this value. So that is dou by dou xi of n1. So that is dou by dou xi of, what is the value of n1 given as? N1 is, we know that don't substitute this constant value because if we substitute constant value, we are going to get completely 0. So before substituting that value, what is the formula? 1 minus eta. So here we have n1 is 1 minus eta into 1 minus xi into 1 minus eta by 4. So that is the formula of n1. So if we differentiate this with respect to xi, so eta will become constant. So this is constant. So constant can be taken as, this value is constant. So eta is constant. So I have taken this outside the differentiation. 1 minus eta by 4 is outside the differentiation and dou by dou xi of 1 minus xi. Okay. So 1 minus eta by 4. So differentiation dou by dou xi of 1 is 0 and dou by dou xi of xi is 1. So this is minus into 1 minus eta by 4. Okay. Similarly, now we can substitute this value of eta here. So minus of 1 minus, what is eta now? Eta is 0 by 4. So we are going to get minus 1 by 4. Okay. Similarly, we have to find out dou n2. So dou by dou xi of n2. So dou by dou xi of n2 formula is 1 plus eta into 1 minus eta. 1 plus xi into 1 minus eta by 4. So differentiation with respect to xi means this value is constant, so we can take this outside the differentiation. So differentiation of this will become 1 plus 1, 0 plus 1. Finally, I am going to get 1 minus eta by 4. If we substitute eta, this will become, eta value is given as 0. If we substitute that, this will become 1 by 4. So the next formula is you have to find out this. I hope you all can perform this differentiation. So I am directly writing down the remaining values. This is also 1 by 4, and this value we are getting as dou n3 by dou n4 by dou xi you are getting as minus 1 by 4. Similarly, this you are getting as dou n1 by dou xi you are getting as minus 1 by 4, and dou n2 by, so this is eta. I am going to write down eta values here below this. So dou n1 by dou eta, after you perform differentiation, you are getting that as minus 1 by 4. Dou n2 by dou eta you are getting as minus 1 by 4. Dou n3 by dou eta you will get as 1 by 4, and dou n4 by dou eta, if you perform differentiation and substitute the value of xi, you will get as 1 by 4. So we got these values here. So the first value I have solved, the second value I have solved. So you have to solve this, all these values. Because it's differentiation and you can do this part. Okay. So after we get these values, we are going to substitute in this matrix and we are going to get Jacobian matrix. Okay. I'm erasing this question here. So now I am substituting that Jacobian. Yeah, what is the first value we got? Minus 1 by 4. The second one is 1 by 4. Yes, 1 by 4. Third one we got as 1 by 4. The last one we got as minus 1 by 4. Dou n1 by dou eta is minus 1 by 4. So here we have to put minus 1 by 4. Dou n2 by dou eta is minus 1 by 4. Dou n3 by dou eta is 1 by 4. And dou n4 by dou eta is 1 by 4. And we can substitute this x1, y1, x2, y2, x3, y3. So x1, y1, x2, y2, x3, y3, x4, y4 values is given in the question. So 0, 0, 3, 0, 3, 2, 0, 2. Okay. Yeah, minus 1, 1 minus, yes. So this is 2 rows and 1, 2, 3, 4. This has got 2 rows and 4 columns, and this has got 4 columns and 2 rows. And the final answer will be, if we multiply this matrix and this matrix, we are going to get this 2 and this 2. So the final matrix, if we multiply these two matrices, will be a 2 by 2 matrix. So it is going to have 2 rows and 2 columns. So one thing we can do here is 1 by 4 is common in entire matrix. So if I can take 1 by 4 common here, so if I take 1 by 4 common here, we have minus 1, 1, 1, minus 1, minus 1, minus 1, 1, 1, because I have taken 1 by 4 common. So I can multiply this minus 1 with this, again with this first row, first element. So minus 1 into 0 is 0, 1 into 3 is 3, plus 1 into 3 is 3. So 3 plus 3 is 6, minus 1 into 0. So here we are going to have 6. Again, first row, second column. So here we have this into this 0, 0, 1 into 2 is 2, minus 2. So 2 minus 2 is 0. Minus 1 into 0 is 0. So minus 1 into 3 is minus 3, plus 1 into 3 is plus 3. So minus 3 plus 3 is 0. So minus 1, 0, 0, 1 into 2 is 2, 1 into 2 is 2. So 2 plus 2 is 4. So that is the Jacobian matrix. So after we obtain Jacobian matrix, the second bit is to find out. So this is 6 by 4, 0, 0, 4 by 4. 4 by 4 is 1. So 6 by 4 is 3 by 2. So 3 by 2 is 1.5, 0, 0, 1. So this is the Jacobian matrix we got. So after obtaining Jacobian matrix, the second step is to find out the strain displacement matrix. Yes. So I am erasing this part, just remember what is given in the question. Okay, I'll erase this Jacobian matrix because the space is not sufficient here.